Hello guys, welcome to Pepcoding, and in this video we will be doing our question stack to queue adapter remove efficient. So what we have to do is you have to write all these body of these four functions: size, add, remove and peek, and you have to make sure that your remove and peek function, both these functions, work in constant time, that is with the time complexity of O1, and that's it. You have to do it. You have done a similar question, but it was add efficient, and now this is remove efficient. So try to do it yourself, and then we will discuss the solution of this video. So I hope you tried it yourself. Now let's discuss what we have to do this question. Okay, so you have to make your stack work as a queue, right? So queue works on the principle of FIFO. That means first in and first out. Whatever comes in first will move out first, right? So in this question, we will be using two stacks, main stack and a helper stack. So this is our main stack and this is our helper stack, right? So if we are told that we have to add 10, so in queue it will add at first, right? And in stack it will add like this. But we have to, if we are told to add 20, right, in queue it will add as this, and in stack it will come above 10, because in stack it is last in and first out, right? So this will not work for us because we have to make our remove function efficient, right? You have to make our remove function work in with the complexity of O1. But if we add in stack like this, your remove function will not work efficiently, because when we are told to remove, you have to remove 10 first, because according to Q, our first, the element that comes first will remove first. So here you have to remove, you will have to remove 10, but you can't remove 10 in the complexity of O1 if you store elements like this in our stack. So how we can resolve this issue is, what we will do is, so we will have to make sure that our in a stack the values are stored like this. First 20 is stored and then 10 is stored, right? And if we are told to add 30, a 30 will come here, and in our stacks it should look like something like this, that first our 30 will be stored, then our 20 will be stored, and then our 10 will be stored, so that we can make our remove function efficient. Let's understand how we can achieve this, right? So we have to make our stack work as a queue. We have two stacks. This is our main stack and this is our helper stack. So for adding, for example, you have to add 10. So you have an empty stack. You can just add 10. We will just push 10 in stack. Okay. Then for adding 20, what we have to do is, you have to first remove this 10 from main stack and append it in the helper stack, right? How we will do that is, first of all, we'll check whether there is an element in the main stack. Yes, there is an element. So we'll just remove from the main stack and we just append in the helper stack until our main stack becomes empty. Now our main stack is empty. So now we can add the value that we have been told to add. So we added 20, and then we do the opposite thing. That means until our helper stack has any element, we will remove from our helper stack and we will add in our main stack. So we add 10 in our main stack. So now this is the required format in which we have to store values in the main stack, so that we can make our remove function efficient, remove as well as peek, right? So if we are told to add 30 now, what we will do is, we will remove until our main stack becomes empty. So first of all, we remove, we pop from main stack, we append in helper stack, we again pop from main stack, we append in helper stack. Now our main stack is empty. Now we append the value in main stack, and we do the opposite thing. We pop from helper stack, we append in main stack. We again pop from helper stack and we appended main stack. Now our helper stack is empty now, so that our work here is done. So that's how we will do our add function. And for the size function, you just have to return the size of main stack, because how many so for the size function, we'll just return length of main stack, right? Self dot main stack. For the add function, while our length of self dot main stack is greater than 0, what we'll do? We'll just remove self dot main stack dot pop, and where we will append this self dot helper stack dot append. We'll just pop from our main stack and we'll just append in our helper stack. Right, now what we do, our main stack is now empty. Now we just self dot main stack dot append the value. Now we do the reverse thing. We check whether our length of self dot helper stack is greater than 0. We self dot main stack dot append self dot helper stack dot pop. Right. For remove first function, it's very simple. We just check if our length of self dot main stack is equals to 0. If this is true, then what we'll do is we'll just print q underflow and we'll just return -1. If this is not true, right? If this is not true, then what we'll do? We'll just pop return self dot main stack dot pop. For the peak function, we do the similar thing. We just copy this. We check whether it is 0, right? If the length is 0, if the main stack does not have any elements, then what we do? We just print q underflow and we return -1, or else what we do? We just store our self dot main stack dot pop in a variable, and we again append this because we don't have to remove, don't have to pop in the peak, no. So we just append tr and we just return tr. Let's try to run this. Okay, so there is some error. Let's check. Self dot helper stack. The S is capital in helper stack. Let's see. Yes, this S should be capital. Now it should work. It's still giving us. Okay, so the S here should also be capital. So sorry for the small errors. I apologize. Okay, now let's try to run. Yes, answer is accepted, and let's submit this, and we have the correct answer.